Okay, so this is our first look at factoring trinomials. We've already looked at how to factor the GCF from a polynomial, how to factor polynomials with four terms by grouping. We want to know now how to factor trinomials. This is going to be an incredibly important skill throughout Algebra 2. So we know the first step in factoring is always to look to factor the GCF. Right? And we've talked about sometimes the GCF might be 1, in which case we just move forward to whatever step is next. But here, the GCF, I can see 6x squared, 33x, 36. All of those have as a common factor 3. When I take that out, I will get 2x squared plus 11x plus 12. Now, my question is, what do I do next? Step 3, I know I need to have this completely unmultiplied. So I want to do some process whereby I go from this to, I'll just spoil it for you, the answer that I'm going for is that 2x squared plus 11x plus 12 is actually 2x plus 3 times x plus 4. And you can check that these are all the same by multiplying them out. In fact, I'll write that off here to the side just so we can see exactly what I'm saying. If I said 3 times 2x plus 3 times x plus 4, and you don't need to write this on your paper, but again, I'm trying to show you what I'm talking about. Well, I need to multiply these two, which means I could do 2x times x plus 4 plus 3 times x plus 4, and then I could further distribute these, 2x squared plus 8x plus 3x plus 12, and then I can combine my like terms here to say, okay, this is 2x squared plus 11x plus 12. All the while, I would then have the 3, which I could then distribute and say 6x squared plus 33x plus 36. So I do know that if I am factoring this, the idea is I'm undoing the multiplication that was done in this forward process here. So I want to go from 6x squared plus 33x plus 36, taking out the GCF, and I want to do something to take this trinomial and factor it down to these two binomials. So how am I going to do that? Well, the idea is to kind of take this whole process and turn it upside down. So what if we took this polynomial right up here before I did whatever magic to get the answer? What if I took this polynomial right up here and rewrote it so it had 4 terms? Because we've seen an idea of what to do when I have 4 terms. Right? So I will take that whole polynomial and write it down here. I brought my GCF along, but really it's just going to come along for the ride. I'm going to put an arrow here to remind myself that it has to be part of my answer, but I'm not going to do any math with it for the time being. So here's what I want. I'm going to look here at this polynomial, and I'm going to draw this little m off of it. Okay? And off this m, this is telling me what I want to do. I want to bring down my first term, 2x squared. I want to bring down the last term, 12. My GCF, I don't need it right now. It's going to be part of my answer. In the middle, right in here, 2x squared and positive 12 are going to come together. I'm going to multiply these two and have plus 24x squared. Again, what I did there was I multiplied 2x squared times 12. And I made sure to write down the sign because the sign is important. So the idea is to split up 11x. I want to rewrite this with 4 terms by splitting up 11x. And in order to do that, I need 2 algebraic expressions, 2 terms that add to positive 11x and multiply to positive 24x squared. Okay? So when you're doing a problem like this, this is what we need. We need 2 things. I'm going to just lightly put some spots here. I need 2 things that satisfy these 2 conditions. So, generally speaking, the variables will be kind of easy. We will have to pay attention to them in the future, but for now, they're pretty simple. But we do need to make a note of the variables. I'm just going to say here, watch your variables, because they can complicate this process in certain instances. But for now, if I have 2 things that add up to 11x and multiply to x squared, well, adding up to 11x means I should have 2 x terms. And then the question is, what adds up to 11 while multiplying to 24? Well, the easiest way to answer this question is to think about what multiplies to 24x squared. Well, what multiplies to 24? That's a pretty short list. 24 is 1 times 24, it is 2 times 12, it is 3 times 8, and it's 4 times 6. How can I get 11? Well, I can get 11 with 3 plus 8. So plus 3x plus 8x. Okay? Now, stop here for a minute. As soon as you've written this down, stop. What were these two numbers supposed to do? They were supposed to add to 11x, and they do, plus 3x plus 8x, that is plus 11x, and they're supposed to multiply to positive 24x squared. 3 times 8 is 24, x times x is 24x squared. So these do work. These are the correct numbers. I'm asking you to pause there and think, because if you're going to make a mistake in this process, in all likelihood it's going to be right here where you accidentally write down the wrong numbers and then try and move forward. And sometimes something bad will happen, and sometimes you won't notice. Now, I forgot to write down the plus with the 12. You got to keep the signs here. This needs to make algebraic sense. And now what I am doing is grouping. Just like how we factored four-term polynomials before, I'm going to group. In this first group, I can see that the greatest common factor is x. If I factor that out, x times 2x gives me 2x squared, x times 3 gives me plus 3x. Over here, plus 8x plus 12, there's a leading positive. I need this sign right there. Keep that positive. What goes into 8x and 12? Well, their greatest common factor is 4. And if I take that out, I get 2x plus 3. Now, if you've done this right, if you've picked the right numbers, these two should always match up, which we know is what should happen when we are factoring by grouping. They do, so I know from here, this means that this is actually x plus 4 times 2x plus 3. And then I can't forget that my greatest common factor is up here. I need that as part of my answer too. So this right here will be my final answer. 3 times the quantity x plus 4 times the quantity 2x plus 3. Or you don't have to say the quantity, but that's my final answer. So as I said, this is the process we're doing. We're trying to turn an unfactored polynomial into a factored polynomial, a product that is yet to be multiplied out. We're turning this process upside down. All right, I'm going to do a couple more examples. Hopefully you can get the hang of it. Nothing real hard in this one, just a couple simple examples that I have in my notes pocket. So right here I have x squared minus 2x minus 63. So I begin by looking for the GCF, and I'll make a note of it here, but you don't have to do this. The GCF is 1. If the GCF is 1, that's not really interesting. I generally just move forward in my factoring. So I'm going to go ahead and draw my m. What does this tell me to do? It tells me to bring down x squared, bring down negative 63. In here, I want to multiply x squared and negative 63 and say negative 63 x squared. And now again, I need two things that add to negative 2x and multiply to negative 63x squared. If your writing is really neat, you can even just, rather than writing this off to the side, which we don't want to do, if you don't feel you need to write this at all and can proceed, great. But you can even make this note up here that we want to add to negative 2x and multiply to negative 63x squared. Just something so that we're getting the hang of this process. Most of the time when you're trying to come up with these numbers, it should be fairly obvious. It should be a fairly obvious pair of numbers. If you're thinking about things that multiply to 63, the things that should immediately come to your mind are 7 and 9. And sure enough, I can make this work with a 7x and a 9x. But I need to be careful. I need to think about my signs. If this has to add up to negative 2x, then do I want a negative 7x and a positive 9? Well, negative 7x and positive 9x would give me positive 2. What I want is positive 7x and negative 9x. Now again, I've written these down. I pause. Did these add correctly? Did they add to negative 2? Sure. Did they multiply to negative 63x squared? There's negative 63. X times x is x squared, so that's all good. So these should work, and the rest of my process should work easily. So I group. X squared plus 7x is x times x plus 7. Negative 9x and negative 63. Well, there's a leading negative. 9 goes into both of those numbers, so I'm going to factor out a negative 9. And when I do that, negative 9 times x gives me negative 9x. Negative 9 times positive 7 will give me negative 63. And again, these two are the same expression, which is how factoring by grouping is supposed to work. So I can say then that, okay, x squared minus 2x minus 63, has the factors x minus 9, x plus 7. That is my factorization. Okay, each of these is a factor. The whole thing is the factorization of x squared minus 2x minus 63. All right, I'm going to do one more example right here. If you follow this process, you can really do, well, I won't say any of these problems. We'll talk about how sometimes problems can be undoable if there are no two numbers that satisfy both of these conditions. But if you follow this process, if you get this process down, you can become very, very strong at this critical skill of factoring. So right here, again, I look for a GCF. They have no x's in common. The terms have no x's in common. 3, 22, 24, no, there's nothing there. So I just go straight ahead and draw my m. And I'm going to write 3x squared, and I'm going to write plus 24. And in here, 3x squared times 24. Well, 3 times 24 is 72. So this is positive 72x squared. So this is one of the biggest challenges that can come up in a problem like this. I need things that multiply to 72x squared. Again, has to add up to negative 72 and multiply to 72x squared. Write this if you need to. Right, so what multiplies to 72x squared? So this is where things can get a little bit difficult. I'm thinking about 72, and nothing is immediately jumping in my mind where I can say, oh yeah, that'll give me negative 22. So I have to make a table of factors. If you have a graphing calculator, if you're allowed to use one, you can do this very easily. Otherwise, you can just use a simple 4-function calculator to do some division. Show you that right here. So 72, I know, of course, is 1 and 72. If I want to figure out how many times 2 goes into 72, I can do that. 72 divided by 2 is 36. And you can just keep going through this. 3 would be next. 3 goes into 72 how many times? Whoops. Helps if I enter the right thing in my calculator, I guess. 3 goes into 72. 72 divided by 3 is 24, which, of course, is what I originally had, so I should have known that. And I can keep going. 4 will go into 72 18 times. You can go ahead and try, but of course we know that 5 does not go into 72. So 14.4, I don't want that. And you can keep going. 6 will go into 72 12 times. And of course the one from your multiplication tables that we should really remember is that 72 is 8 times 9. 7 does not go into 72. So those are all of the factor pairs that give me 72. Now really, I could have stopped before I wrote down those last two, because what was I trying to get? 22. And how am I going to get 22? With 4 and 18. So, 4 and 18. I know I want 4x and 18x. If they are to add to negative 22 and multiply to positive 72, then that means I want two negative numbers. Now again, be very careful. Some of these seem easier than they actually are, can lead you into little traps. You got to pay careful attention to everything that you're doing. Don't try and fudge the details, because if you fudge the details, your answer is not going to be right. And of course, I'll notice, and it's not helping you anyway. But yes, negative 4x minus 18x, that does combine to negative 22x. If I multiply them, negative 4, positive 18, excuse me, negative 4 and negative 18 multiply to positive 72, x times x is x squared. So this should work. And then I can group these and say, okay, this is x times 3x minus 4. This is negative 6 times 3x minus 4. These two are the same expression, so I should then have the correct factorization. X minus 6 times 3x minus 4. That should multiply to give me 3x squared minus 22x plus 24. And I can check by multiplying out in some fashion, whether that be FOIL or using your little box or just split it up and distribute. But the idea is right there, that is the splitting it up and distributing. If you want to check, you can. X times 3x minus 4 minus 6 times 3x minus 4 is 3x squared minus 4x minus 18x plus 24. Negative 4x, negative 18x is negative 22x. No other like terms to combine, and that is what I wanted. So I have checked my work, and I know that that is indeed the correct factorization. Hopefully this has been helpful.